Hey guys, so today I'm going to be recording a problem in JavaScript called heads or tails, and I'm just going to read off and you can see it on the screen as well. It's challenge 8 in CS bin of Codesmith for people that care about that. But anyway, it's called heads or tails, and what it has to do is basically return all possible outcomes of n number of flips. It says games, but it's really, flipping the coin. And it's going to be heads or tails. And depending on how many flips, it should return an array of arrays. So a 2D array that contains, one array, master array, outer array, you might want to call it, that returns a collection of arrays which represent what happened on heads or tails on each flip of the coin, and return all possibilities depending on an n number of flips. So if you flip the coin twice, you can have heads, 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 tails, tails, heads, or tails, tails, meaning one of each is not the same as the other. So heads and tails is not the same as tails and heads because they're on different flips. So that would count as two different possibilities. So immediately what we can say is that the number of results should be 2 to the power of n. So for example, if you have 3 flips, that would be 2 times 2, which is 4 times 2, which is 8. So you should have 8 possible outcomes. And you'll see that on the examples in lines 9 through 16, for example, if you had 3 flips. And on line 6, for example, if you had 2 flips, you'd have 4 outcomes, and then 8 outcomes, and then 16 outcomes, and then 32 outcomes. So you always have double the outcomes of however many you had in the flip before it. So the number of arrays is going to increase exponentially. Not sure if that's the right terminology for that, but yeah, the number of results is going to increase by a lot. And the challenge is also to do this recursively. So even though recursion is not great from a performance point of view, that's the approach we'll take. And it also happens to be the only way that I know how to do it. So I have already done this problem. I didn't review it like 100 times. I just have completed it. So don't feel like I was able to do it this fast and therefore I'm great and you're not, or anything like that. I did practice this a little bit, so it's not going to go completely smoothly, maybe, but I have done it before and very recently, so I'll have some idea how I'm going to approach this and how to code it. Okay, that being said, let's get to the code. So hopefully you guys can see the screen right now. And the function is already kind of outlined for us, the format. And I'm not going to be using any helper functions or anything like that. I'm just going to code it all in this function. So the approach I'm going to take, and I'm going to explain this as best as I can, and you guys can let me know if that made sense for you or if I need to further clarify it for anybody. And I'm not going to promise that I'll do that, but I'll take notes and try to make future videos more clear or increase my technical communication ability. So I have the file already with the syntax highlighting ready, and yeah, let's do it. All right, so my approach for this is going to be, and I just said that with each additional flip, the number of possible outcomes increases by 2. So the approach that we take here, and this is kind of the trickiest part of the problem, is even kind of trying to think about how you would approach a problem like this. If you haven't seen something like this, it might be very difficult to come up with a method. So the method that I used, and I think is going to be the method that many people almost have to use, barring some amazing way that at least I haven't thought of yet. So basically on the very first flip, and each flip basically, there's 2 possibilities. So if n was 1, then we would get an array of heads and a separate array of tails, just one of each, and that would be like our starting point. And for the recursion part, what we would recurse is for the number of flips. So we would do something for each number of flips and update the array. This is the approach. Update the array depending on each additional flip and subtract 1 from n, so that every time it's recursed, n is reduced until it reaches, say, 1, because that would be our base case. So we're going to give it an array that would be head or a tail, and that would be the starting base case, and we'll recurse for every value that n is above 1. So if it's 2, we'll recurse once. If it's 3, we'll recurse twice, and so on and so forth. And we'll increase the array based on that, the array of arrays. So not sure if that made sense, but basically what we're doing is we're building up the array. So if n is 1, then the array will be head or tail. And then if it becomes 2, we'll push additional data into the array so that the array is representative of all the outcomes possible for if there were 2 flips or 3 flips or n flips. All right, it's very difficult to explain the approach, so hopefully that was as clear as I can reasonably be, and I'm going to get started. And one of the first things that I'll want to do is add a parameter to store the array throughout the recursions, and it can't be in the body of the function because then it will be run every time it's recursed, and it's just not as easy to deal with. I can't really see how you would deal with it very easily, nor do we want to pollute the global environment with a global variable. So we'll put it in the parameters. So I'm going to add a parameter, and we'll call it final array. And I'm also going to give it a default value, which is an array of arrays, so 2D array, and it's going to contain heads and tails. And one thing I want to point out here ahead of time is that you see the example in, for example, line 6 or line 9 through 16 has a particular way of displaying the order of the outcomes. My particular solution is not necessarily going to match that. The question asks that it returns all possible outcomes. It doesn't say in any particular order. So we're just going to focus on getting all the possible outcomes and not on the exact same order as the example such as 9 through 16 for n equals 3. So that's one potential solution, but as long as all the same combinations in the same slots, so the first column represents the first flip, second column, second flip, third column, third flip, and so on. But the order, the rows, it can be in any order as long as they all exist. So as far as this formatting, for people that are not familiar, the equals just means if no argument is passed in for the second parameter, then it will default to whatever value is to the right side of the equal sign. So we're going to start it off with the array that would exist if n was 1. And actually this is slightly mistaken, so apologies ahead of time. These should be individual arrays because they represent 2 different possible outcomes. They're not one possible outcome. It can't be both heads and tails. It has to be heads or tails, which is why they're separate arrays. They're separate outcomes. So when you flip the coin once, there's 2 possibilities, right? Heads or tails. Hence, these are 2 separate arrays. So we're going to start off by preparing for an edge case, and that would be if there are no coin flips, then I think I would have to deal with that specifically. So I'm going to start off with if n equals 0, then we will return an empty array because, right, there's going to be no arrays if the coin is never flipped because there's going to be no outcomes. So we're just going to take care of that edge case, and that's not the base case, that's an edge case. So now we're going to do the base case, which is when we recurse, we're going to subtract 1 from n every time. So eventually n is going to reach 1. So if n equals 1, then we're going to return our final array, which we're going to be building by running the recursion. All right, so that is sort of the initial setup. And now we have to figure out what we have to do in every recurse instance of recursion, every loop in the recursion, what has to be done. Now, the approach here is that we're building the array, right? So first we start off with heads and tails. That array is already going to be there. We need something to work with, which is why I pre-populated it with an array. Now, if we were to increase the number of flips, so that we've already taken care of one flip. But if we do 2 flips, and I kind of found it helpful to think of it like a binary tree. So you have one possible outcome, head or tail. So let's say it's head. So you'll have like a little section, you know, like a circle, a node that says head, for example. Then it has 2 possibilities, right? So it's going to have a head or a tail possibility. So what we have to do is populate. So first of all, we have to duplicate these arrays because there's going to be a possibility where it's head and a possibility where it's head and tail. So we have to take that heads array, the first possible outcome, and duplicate it so that we have a head and a head tail. So what we're going to do first is we're going to duplicate the initial array. And how we do that is I'm going to use a for loop. That's just what I'm comfortable with. But it can be done with any loop you like, as long as you can manipulate the data in a similar way to how I'm about to do it. So I'm going to do a very traditional for loop. Let I equals 0, I is less than, and the number of loops will be, let me think here. We have to do, I believe it's final array.length, if I'm not mistaken. So let me just do that. Final array.length and I plus equals 1. I just like to do that. I've heard it's more clear. I've heard that from a couple of experienced engineers, and so I'm going to do plus equals 1 rather than plus plus. It's not something that I can explain why I do it. I do it because people advise me to do it that way. It's not a huge deal from what I understand, so don't trip over it too much. All right, so I'm not 100% sure that it's final array.length, but I'm going to go with that for now. I'll change it if I realize during coding that that's not the right approach. And what I want to do is, maybe even before I do this, actually, let me think about it for a second. I'm going to actually make an additional variable, which is the value of the length of final array before it's updated, because once we push additional values to final array, then final array.length will change in value, and that won't be good, because then we could go into an endless loop, because we'll be pushing into final array.length will increase, and the loop will never end because the condition to exit the loop will keep increasing and we'll never catch up to it. So actually I'm going to create a variable, not a constant, and let me just think about that for a second. Can we make it a constant? I believe we can. Let's do constant. Const, let's say current array length equals final array.length. So when that gets updated, this value will not be updated because it's not an array, first of all, so it's not a reference to, point to something. It's actually its own value. So that means when final array changes, current array length is not going to change because it's a number, it's not the actual array. Same goes with final array.length. It's a number, and so it will be its own value. It's not a reference to anything like an array is. All right. Speaking of, and what I just foreshadowed there is when we want to duplicate these arrays, it's a little bit tricky because you want to make sure you don't just point to the same array. You want it to be its own individual array. So that can be a little tricky, and I'm going to have to fumble around and make sure I can do that correctly. So first of all, let's only go to the current array length. All right. So that value won't change. So once the array gets longer, we're still heading towards the same value, and we will be able to exit the loop. So that's just a little bit of a mistake I made there that I'm correcting now, so I won't go into endless loop when the code is run. All right. And what do we have to do? We have to duplicate, first of all, the current values in the array. So the outer array stays the same, but it gets populated with 2 more arrays, which are going to be heads and tails. Now, how would we do this? Well, we can Well, first of all, we have the correct approach in that we're using a for loop, but it's not that simple. We still have to, I believe we'll have to push. So let's start with final array dot push. And what do we push in? We would be pushing in final array at I, and it would be, so right now we would be pushing in the array itself, which does not help me. What we need to do is push in the value inside the array. So I'm going to be using the spread operator on final array at I. And what that does is, so right now final array at I is going to be this entire array, including the brackets. So it's an array, it's not a string. And what we want to do is not copy an array, because that'll be a reference. It won't be an actual duplicate. It will be the exact same array. Meaning if we then change the contents of heads, both our arrays will now change, and that's just not right. That's not what we want. We want to instead push in an array, a new array that happens to contain the same string heads. All right. So first we're doing is we're using the spread operator on final array. And by doing that, we're not getting this whole area I just highlighted, not including the brackets, not the array, but the actual string is what we'll be getting, because we're spreading it out. We're removing the array brackets, and now we just have heads itself. So we're pushing just heads according to our code right now. But we don't want to push just heads. We want to push a brand new array that happens to contain the string heads. So we'll want to, sounds redundant, but by doing this, we're getting a brand new array rather than pointing to an existing array. So now we're pushing a brand new heads into the final array of arrays. We're adding a new array. So once we do this, what it'll be doing is something like this, just as an example. And of course, we also want to add tails like that. So we want it to be brand new arrays. We don't want this heads at the second index value to be pointing to the same thing as this index value, because then when we change this value, which we'll do here, it'll be the exact same for here, and that's just not going to work for obvious reasons, I hope. So that was just for illustration. I'm going to remove these now, and we will continue. So this will push each string as new arrays into final array. And let's test it. Console.log final array. So we'll see what the final array is at this point, and we'll uncomment the test that is testing with n equals 2, just so it'll run, because it's a function, won't run unless it's invoked. And we get heads, tails, and they're not the same. That part we can't see in this particular example. And we get undefined because the function is not returning anything. Therefore, by default, it returns undefined. All right, so we have, I believe, what we want so far. The only thing we don't know is, are those two array values different? So I guess we can find out by changing what we log here. Just making sure. I'm actually fairly confident they're different. But what we can do is, now that we know that final array has 4 values, we can say is final array at index 0, is that, well, first of all, let's log them. Final array at index 2. So these should both contain strings of heads. So let's start by logging that, and they're both heads. So now what we can do is remove the comma and say, are they strictly equal? And they should be false. And they are, which means they're not the exact same array. So we have exactly what we want. And just as an example, if I redo this without the spread operator, let's say. So instead we're pushing final array at I, and we'll comment this one out and add a new console log. Console.log and just print final array in the log. So now we should still get, oh, there is a syntax error. My mistake, I have an extra bracket because of the spread operator, and I forgot to remove it. All right. So we still have an array that looks like it's correct. The problem here is now we're pushing final array at I, we're pushing the entire array. And so what should be happening is array at I, array at 0 and array at 2 should actually be pointing to the exact same array. Meaning if we did something like, for example, change final array 2's value. So right now we're only pointing to the array itself, but we want to change the inner value, which will be 0. So if we do that and we change it to new value, and I have another console log to log the final array after the change. Notice I'm only changing one value, but because the array at 0 and 2 are now pointing to the exact same array, so when I change the value contained within an array, it will change the value in both the 0 position and the second position if we were to be counting 0 indexed. So might be quicker to just show you rather than explain it to you. So you'll see in the first array we have what seems like what we want, a heads, a tails, a heads, and a tails. In other words, we duplicated the arrays contained so that we now have 4 arrays. But we haven't actually done that. The array here is actually, the contents will be exactly the same as these, which means when we changed the contents, by adding this 0, we're changing the contents, not the actual array, to a string of new value only on the second position. It's also changing the array at position 0 because they're the exact same array. They point to the same part in memory. And that's not going to work for our code. So this is an important point and could make this problem tricky that we have to distinguish. And that's why we instead extract the contents of the array, not the array itself, not including the brackets. So if I highlight it here, if we don't put the spread operator, we're taking the entire array and we're just trying to duplicate. But by trying to duplicate, we actually just simply point to the same position in memory. But by spreading with these 3 dots, we're only taking what I'm highlighting now, which is the contents of the array. So we're taking the string and we're putting it in the array. But of course, now that has to be an array, which is why, I know it sounds complicated, but stick with me here, which is why we're putting array brackets around the entire thing. So first we extract the raw data, which is the string heads or tails, but in this case, let's focus on heads. We extract the raw data by using the spread operator. So now, before we wrap it in brackets, the data being pushed is the string heads with nothing around it, just the string heads. And by putting a bracket, now we're pushing an array that contains the string heads, but it's a new array. It's not the same array. So it seems redundant, but we're getting very different results. And this is the result that we want. We want a brand new independent array that has its own values that when you modify the contents will not affect the contents of the existing arrays in the final array. So that being said, and hopefully all of this made sense, and that's why we're doing the spread operator and then the array brackets around. So it seems kind of redundant, but it's actually not. It serves a very different purpose, and we need to do it this way. And by doing that, we'll get something that looks like this right here, but will behave the way we expect. So that when we change only the value here, it will not change the value of the array that it's supposedly copied. All right, so now we have an array with 4 values, and we have a second flip. So what we do is we have to add an additional possibility for each outcome. Meaning right now we have what you can do in one flip is you can, in the first flip, can be heads or tails. But now that we have a second flip, it can be first flip heads, and then the second flip can be a head or a tail, which means we have to double the number of arrays. And there'll be 2 arrays that represent the possibility of having heads as the first. But within those 2, so that's actually one outcome. Let's say there's 2 arrays that both have heads, but one on the second array can be a tail or a head. So it can be head head or it can be head tail, which is why we duplicate the results of the previous recursion, and then we add either a heads or a tails, or actually we add both, the heads and the tail possibility, to a single possibility from the previous round, if that makes sense. That's why we have heads heads, but we have head tail, and then we'll have another 2 arrays that are both tails, and they can also have a second flip that could be heads or tails. So I hope that made sense. I know it's kind of difficult to explain and difficult to picture, at least in my head when I first thought about it, but I'll keep coding and maybe it'll make more sense to you as you watch the code. So next, so far our loop has done what we want it to, but now we have to add the additional 2 heads and 2 tails, assuming that we're doing n equals 2 now. And we're coding this before we recurse because we just have to have the code that occurs in one loop. If we were to use n equals 2, then we already have the result for 1 and we just have to modify it for 2. So we're simplifying the code by only coding for one iteration, and then we're going to YOLO it into a recursion and hope that it consistently performs in each following recursion, which you'll find is the case here. So what we need to do is have another loop. So we'll do another loop, and I'm going to use the same variable here of I because they're in different block scopes. But if that's bad practice and anybody knows that for a fact, please let me know, and what you think the alternative should be. For example, should I use different letters? And I will consider it and consult it, and if everyone seems to agree, I will update to try to adhere to best practices. That being said, so what we want to do here is a little bit tricky. We want to go from I equals 0 to I equals half the value of the now 4 length array. So we want to go to 2, and we happen to have a variable that represents the array before it was modified. So this array, current array length, still contains the value of 2 in our specific example here. I plus equals 1. The reason I'm doing only from 0 to 2, even though the array's length is 4, is because for half of the results, so not necessarily 2 in a follow-up recursion, but in this particular example where we're going from the results of n equals 1 to the results of n equals 2. So in that specific example, what we want to do is take half of the now updated number of elements in the final array. We want to take half of those and give them heads and give half of them tails. So that's why I'm doing 2 separate for loops. May not be the cleanest way to do it, but this is how I solved it, and it might be possible to refactor it. And we're going to push additional strings of heads in half of our results and tails in half of our existing arrays. So like I said, I'll code it instead of explaining it. It might make more sense to you. So what we do is final array, and I believe we're actually even going to do I here because we're going to be picking specific arrays. So now we are selecting, by doing the code bracket I, we're selecting 0 and then 1, and then it won't run anymore because it'll reach 2 and because of the less than symbol. So by using the I, we're selecting this or this, depending on the iteration we're on, the entire array. And since it's an array, it has a method called push, and what we're pushing in is the string heads. And then we'll have a second for loop, and we'll start it at 2, which we happen to have a variable for, current array length. And we want it to be dynamic. That's why we're using not a hard-coded number. So current array length, which will be half of the total length of the array now that it has been modified. And we're going up till the length of the final array. So we'll do final array.length, which in this particular case, if we're going to n equals 2, would be 4. And I plus equals 1. And so for these two arrays that we're now selecting, essentially the final two arrays in the array, we'll be pushing, instead of heads, we'll be pushing tails. At I, so that selects the array, and therefore we have a push method, and we're not pushing to the entire final array, we're pushing into the individual arrays contained within final array. That's why we have to select them using I. Dot push, and it'll be the string tails. Oops. So at this point, I'm going to run it with 2 because this should work, but there is one final step, and that's obviously to recurse. There's no recursion in this function yet. So first we'll run it with the value of 2, and we get undefined because I'm not returning anything. Or am I? Oh, because we're not recursing. So in this case, what we can temporarily do is return final array. Array. So because we don't have a recursion, and that looks correct. It has a heads heads, a tails heads, a heads tails, and a tails tails, which is correct, although not necessarily in the exact same order as the example. But for the purpose of the question, it's fine because all we have to do is come up with all possible outcomes. It does not say order. All right. So the problem is, and you can probably guess, this is very specific to if the passed-in value of n is 2. So when we do 3, it will fail. It will only do the array for 2. In other words, this code only works for 2. But in order to make it work for every number, instead of returning final array, we return heads or tails. So the return value of invoking heads or tails with n minus 1 and final array. So now we're passing in this new final array here becomes this in the new recursion iteration. It will ignore all of these because n is not going to be 0 or 1. Or if we start with n equals 2, then n minus 1 would now become 1, and so we'll return that final array, which is correct. If n was 2, this would still be correct. If n was 3, then when we pass it in, it'll still be 2, and so it'll skip the first two if statements and go into current array length equals final array dot length. And at that time, the final array dot length is going to be, so the passed in array will be now 4. So current array length will become 2. Is that right? I'm sorry. If it was 3, then that's actually not true. Well, actually, it's true. Yeah, only n would be 2 now, so it'll be updated for the next iteration. So that's fine. So yeah, it would actually be 2. And all of this code would run. It will push in an additional heads and tails. It'll make a duplicate copy. So the array would be 4 values, would become 8. And then it'll run again. The array will be twice as large. And it'll be subtracted even more. And now there will be 8 values, twice the number of one less flip. So there'll be 8 values. They'll all be unique. Then n will become 1, and it'll return the final array. So this should work. Sorry if that last part was not super well explained. I kind of lost myself when I was simulating the recursion iterations on line 22. And I'm scrolling the wrong window again. But you'll see that we get a result. And maybe seeing this result will also help you understand the solution. So we start off by just simply copying the existing array. The existing array at the very beginning at n equals 1 is heads and tails. So it copies heads, tails. If there's another iteration, it'll copy heads, tails. If there's another iteration, it'll copy all 4, meaning now it'll have another set of heads, tails, heads, tails. So it doubles each time, meaning first you'll have a heads and a tails, then you'll have a copy of that, so you'll get another copy of heads, tails, but when it copies that, it now copies the entire 4 arrays. So it'll become heads, tails, and for each of those, we're pushing a heads, and then a tails, and a tails, which makes them unique, because you're pushing a heads and a tails to both a starting value of heads. So if the first value is heads, as you see in line 1 and 3 here, in the output, then it's getting a second roll of both, not a roll, a flip of both a heads and a tails. And if you had a tail as the first, then you'd be again getting a heads or tails on the second flip. And if there was a third flip, then now you can have a heads and a second flip of heads, which is these first 2 lines, and you can have a tails or a heads. So the order is not exactly great. Oh, I'm sorry, I think I even selected the wrong output there. Let me see if I can square that out. So we have, right, a heads or tails, and then if the first 2 are heads, you can have a tails, or if the first 2 are heads, you can have a heads in the third flip. So yeah, it does accommodate everything. It's just my explanation may not be perfect. But basically, it takes the first half of the previous length of the array, of the length of the current array, and gives them heads, and half of them it gives tails. And if it keeps doing that, you'll get all the possible outcomes, and they'll all be unique. So this is the solution. Apologize if the explanation wasn't perfect, but I tried my best, and I especially wanted to cover the reason why I did the spread operator and the array brackets in line 12 in a lot of detail. So I hope that helps, or at least gets you guys to kind of understand how to solve this problem, and that will be that. Thanks for watching.